All right, chapter 3.2 is about some of the tricky graphs that we're going to have to deal with, solving systems of inequalities by graphing. It looks at graphs of multiple, this section itself looks at graphs of multiple inequalities. It is best to look at our basic graphing challenges before actually attacking it, so making sure that we remember how to graph these basic things before putting everything together. So not sure if you've gotten used to this yet, but whenever you have something like y is greater than or equal to 3, the first thing I always say is go to where y is 3 and keep in mind that the tick mark goes that direction, which means that's the direction that you're going to go. Testing 0, 0 if it's greater than 3, or you could think about this, numbers that are bigger than 3 are going to be above the line, but you could test 0, 0, 0 is less than 0 is not greater than 3, so therefore you would shade that way. X is less than 1. Again, go to where 1 is. Just remember again that it's going to go this direction, so you have your dashed line going this way, less than 1. 0 is less than 1, so you would shade that side. Those graphs kind of come into play with some of the stuff you're going to see in realistic stuff. These don't really pop up on the test much, but they do pop up in your experiences, and I want to make sure that you are ready for those. 2x plus 3y less than 6. Remember, keep in mind here that what we do is first off ignore the x, find out that x is 3. Ignore the y, find out that x is 3. Ignore the x, find out that y is 2. Don't forget that this is a dashed line, so you do want to use some sort of a straight edge when you do these because the location of 0, 0 is important. And then testing 0, 0 means you get 0 plus 0 less than 6. 0 less than 6, just moving the opposite direction on my solving. That is actually true, which means that it would go this direction. And then y is greater than or equal to 1/4 x plus 5. This is slope intercept form, so it means we go up 5, 1, 2, 3, 4, 5, and put our dot down 1/4 dot solid line this time because of the line underneath it. I think this is more of a review right now. I hope it is because I think we've done this already. And then 0 greater than 0 plus 5, 0 greater than 5, which is false, so therefore you would be above that line. And so with that being the key idea, that's the 4 graphs of basic lines. You have the horizontal line, which is a y equals graph, you have an x equals graph, you have a standard form graph, and you have a slope intercept graph. Those are the main 4 graphs that you need to go to for a line. Then we get into the absolute values and some of the weird ones. Keep in mind your absolute value, that means 2 to the left because remember that's a -2 and 3 down. So you go 2 left, 1, 2, and 3 down, 1, 2, 3. The basic graph is over 1, up 1, back 1, up 1, and it is a V. Also, it's a V with a dashed line going through it. So we go this way and that way. The reason the ruler is so important is because if you're not accurate, then you don't know if you actually caught 0, 0 in the appropriate way. Now, if you draw your line this way and curve badly enough and it goes above or through 0, 0, you never know. But at least with a graph like that, or you use the fact that it's over 1, up 1, over 1, up 1 means that yes, it's pretty accurate. So testing 0, 0. I'm going to actually do this here because I need to make sure I get it right. 0 less than 0 plus 2 minus 3, 0 less than 2 minus 3, 0 less than 2 minus 3, 0 less than -1, which is false, which means we stay on the outside of that graph. I haven't done this in a while. I might be wrong, but I think I'm right. I'm pretty sure. Again, that would be 0, which would be 2, 2 minus 3, -1, and -1 is less than 0, so that would not be the case, which means I believe we are correct. When you get a graph like this, and what I've been trying to tell people is there's basically 2 ways to graph, which is standard form and slope intercept form, and it's kind of your job now to look at it and figure out what is the best way. Whenever I see y by itself and I realize that if I just move that over, it becomes y is less than or equal to 2x minus 1, it means the best thing for me on this is slope intercept form. The other way to think about it is if I move y over here, I have to divide by 2 to get my x-intercept, which means I get 1/2. Thinking about it that way, it means that, again, slope-intercept's probably the best, so go down 1, then up to over 1. And again, you're going to have a solid line here, so let's do that. And then we test 0, 0. So 0 plus 1 is less than 0. So 1 is less than 0, which is false. So we would stay on, let's see, let's make sure 1 is less than 0, which, yes, is false. So we go on this side. Again, this is review, or should be review, more than anything else. The only difference is that these graphs are now crazier because it requires for us to actually be able to manipulate some things. Same thing here. There's two options here. You could move the y over, move the 3 over, or you could, there's two ways. I actually do both. So one is to take x minus 3 greater than negative y and simply flip it all the way around, which means that flips, which means x minus 3 goes here. So we literally took that and moved it over, took that and moved it over and flipped the sign because it was pointing at negative y. And then because we want a regular y, you would end up with y is greater than negative x plus 3. That's one way to do it. The other way to do it is to move your y over here while you move your 3 over there, which means you end up with x plus y greater than 3. Notice the sign doesn't change in that way, but also notice that if you did this, you would have y equals negative x plus 3 over there. Again, your x would be negative, your 3 would still be positive, your y would be alone. So either one of those two works. This would be an x-intercept of 3, y-intercept of 3, whereas this tells us to go down 3, or sorry, up 3, 1, 2, 3. There's your y-intercept. And then you would go down 1 over 1. But notice if I kept going down 1 over 1, there's your x-intercept of 3 also. So again, either one of those two things works. Just make sure you've got both of those methods under control. Dashed line, because it's less than. Testing 0, 0, 0 minus 3 is greater than 0, negative 3 greater than 0, which is false. So we stay on this side. And number 8, to me, we could do the intercept method, but when you divide 4 by 3, I'd end up with a fraction. So to me, I'm probably going to say, since 2 goes into 4, that the dividing by y gives me a nice number, so I'll probably choose the slope-intercept method. So I'll get 3x plus 2y. Actually, I'll move both of these over because I want y by itself. So it'll be 2y less than or equal to negative 3x minus 4. And then when I divide everything by 2, I get y is less than or equal to negative 3 over 2x minus 2, which again is where I knew if I divided by the 2 attached to the y that I'd get a nice number. So down 2 dot down 3, 1, 2, 3 over 2 dot solid line here. I've never been good with rulers. And testing 0, 0 gives me 0 plus 4 greater than or equal to 0. I'm sorry, less than or equal to 4 less than or equal to 0, which is false. So again, we will stay over there. So the first set of graphs was the basic graphs that you need to deal with. These graphs were both the absolute value, which you're going to need to know for the quiz. Graphs like this, which you're going to need to know for a quiz, where you'll switch it around. You'll need to know how to do something like this for the quiz. You need to know how to do something like this for the quiz. So these three graphs here, this graph here was just making sure you remembered how to do your absolute values because you're going to need it. And then the other three were just basically to make sure that you see the types of things that you need to be ready to do upon demand. Because I believe you saw graphs like that last chapter, whereas this time we're going to have systems of graphs, which means multiple graphs. So shading of systems of graphs requires that you can find what the multiple graphs have in common. Will not only graph specific systems so as to give you more time to practice on your own. Instead, we'll look at graph systems and shade accordingly. So I'm not going to have us graph right now because it'll take up too much time. What I'll do instead is give you the graphs and talk about how to shade. So be sure you understand the new portion of the concept before allowing me to move on. This side of the page actually represents work for the section. So going here, I've already set up the graphs. I've labeled them A and B, and I'm telling you what the graphs did. So if A is true for 0, 0 and B is false for 0, 0, I would use a method that I simply call for my 4-way students and 5-weight students finding the alligator. And so what I say by that is, if A is true for 0, 0, that means it will go this way. And so instead of shading all the way, I put a series of waves, which I will call teeth. And if B is false for 0, 0, that means it would go away from 0, 0, so it would go this way, following the line of B, again, above B to the right of A. And if you look, that doesn't have two sets of teeth. This doesn't have any teeth. That has one set, but this has two. That would be the section that you're going to graph. So it's a simple game, finding the alligator or using those wavy lines to kind of do it, because what it prevents you from having to do is shading all this, shading all that, and then having to rewrite. Now, if you want to do it that way, that is fine. Another way I've seen it done is where you draw vertical lines or perpendicular lines from each one. So perpendicular that way, perpendicular this way, and where you see the two intersect is the section you would actually graph. But however you do it, just make sure you know how to find the section. But to me, this is typically the way that works best for me, because I can visually see it on the paper without having to make a whole bunch of marks and losing my focus on what's going on, especially whenever you get to 3 or 4 graphs at a time, which at some point you do. A is false for 0, 0, which means that, again, A is going to be on this side of the line. So again, what I do is I draw a little set of teeth or wavy lines on the left side of A. B is false for 0, 0, which means that we're going to, again, stay on this side of B. And if you look at that and just kind of glance, you should be able to see where the alligator is. It's not here. That's one set, no set, one set. It's going to be on this side. And so that's what you're looking at and what you're trying to make sure you can do. Number 3, even if you have graphs like this, A is true for 0, 0. So this graph is true, which means we're going towards 0, 0. But watch how I follow this whole shape and stay on the outside. B is false for 0, 0, which means that we are looking at the top section. And when you play finding the alligator, you recognize that there is one over here and that there is also one over here. Yes, it's above, but it's outside of there, so it's going to be these two sections of your graph. And so that's what we're looking at. All right. What if A was false and B was false? Well, if A is false, that means that we are looking at the inside of the graph. So again, we would go here all the way down and all the way up. And if B is false, we're going to again stay above. And in this situation, no, 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 because that's blank on the top. No, because that's blank, blank on the top. It's going to be this upper section here that is represented. And so again, as you get multiple graphs, that's what you're going to be looking at doing, is trying to get used to finding that section depending on what's there. You will also have on your homework, on the Math Excel homework, somewhere X and Y can't be negative. They'll just say X is greater than or equal to 0, Y is greater than or equal to 0. That means they can't be negative because they need to be positive. These are usually in multiplication or application problems where, of course, it doesn't make sense to do that. So with that said, A is true, which means we're going to go towards. B is false, which means we go away. And then, as they say, X and Y can't be negative, which means we want everything above this line and everything to the right of that line, which means, again, you're looking at, has to be in this quadrant, and it has to fit, which to me means we're looking at this section here, but we stop at the y-axis because, again, y can't be negative, so that would be the triangle that you create based off of that. Okay, so again, with all that said, that's pretty much what you're looking at doing there. All right. A is true for 0, 0. B is true for 0, 0. X and Y can't be negative, so A is true, which means we go towards. B is also true, which means we go towards. Can't leave the axis of X and Y being negative, which means that those are cut off. And notice that this is the alligator, but as that alligator goes, it can't cross out of that gate, which means it has to stay inside of here the whole time. And so you're looking at, I guess that's a trapezoid, as you'll learn next year. But like I said, that's really where everything's going with that. Okay, so there will be another video, and this video is actually very important to you because it actually has some of your test questions in it. The Math Excel homework is important, but not as important as the video that I'm going to be going over next. The Math Excel is practice because I need to keep you preparing and getting better. But the video that comes after this is actually homework that is integrity homework, I guess is the best way to say it, because it's going to be set up to where you watch the video, but at the same time you should pause it, work it out, and see how well you did, and then make your adjustments, because again, the video that comes up after this is actually preparing you for the quiz, whereas Math XL is just giving you some practice. So be sure to watch 3.2b so that you can actually see the homework and do something like that. Like I said, you don't need to finish it all at once, but understand that inside of that chapter 3.2b is your quiz work, or is your quiz homework. So make sure you go through that, because again, I won't give you everything and I won't give you blatantly what the quiz homework is, but the quiz homework is on there. So I'll talk to you later, and let me know if you have any issues with this.